So this is question number 1 of chapter number 5, which you can find on page number 100. The question says that a 30 kilometer 34.5 kilovolt 60 hertz three-phase line has a series impedance Z equals to 0.19 plus J 0.34 ohms per kilometer. The load at the receiving end absorbs 10 megavolt ampere at 33 kV. Assuming a short line, calculate the ABCD parameters, the sending voltage for the load factor of 0.9 lagging, and the sending end voltage for the load power factor of 0.9 leading. And part D says compare the answers of B and C and give your comments. So for the first part, the question is asking about the ABCD parameters, but it also says that it is a short line, and as you know that we don't have ABCD parameters for short line, they are actually for medium line and long line. But because it is a short line, what do we assume about the shunt admittance, which is Y, the reciprocal of J, the reciprocal of shunt capacitive reactance? Because capacitive reactance of a very short line is infinity, is very high, so this is the inverse of capacitive reactance. So any number over infinity will give you 0. So because shunt admittance is 0, whichever style you use for the transmission line parameters, the pi or the T shape, if you put the value of shunt admittance to be 0 in those parameters, you will find out that A just comes to be 1, which is the same as D, and C will come out to be 0. The only thing left with us will be B, which is actually equal to Z, our series impedance, which is given in the question. Because the length is 30 kilometers, we multiply this with 30 and we get 5.7 plus J 10.2 ohms. So these are the parameters for part A. For the second part, it is asking you about the sending voltage. So how do we calculate the sending voltage? The first step for that is to find the current for the receiving end. The formula for the apparent power is square root of 3 times VR and IR line to line. And from there you can solve for IR. It comes out to be 175 amperes. And because the question says that it is 0.9 lagging, so the angle of this current comes out to be negative 25.84 by taking the cosine inverse of 0.9. So this thing is actually the same as the sending current because it is a short line. Because it is a short line, IR will be equal to the IS. Now, to find the sending voltage, the formula that we have in our book is Vs over square root of 3 equals to VR over square root of 3 plus IR into Z. So just plug in the values of all the variables that we have here and then multiply this whole thing on this side with square root of 3. We get the value of the sending voltage to be 36 kilovolts with the angle of 3.2 degrees. Now, in part C, it says that you have to calculate the same sending voltage, but instead of 0.9 lagging, you have to calculate at 0.9 leading. So the only thing different here is that the angle will be positive because it is leading. The angle of the current will be positive 25.84 instead of minus 25.84. And then just plug in this new value of current in the same formula to find the Vs, the sending voltage, and you will find it to be 33.4 with the angle of 6.1 instead of 36. So the part D is saying that you have to compare both of them. You can see the difference. After using leading instead of lagging, you can see the difference in the sending voltage. It has reduced and it has come actually close to the receiving end, which is 33 kilovolt here.